You open your company's app launcher and click a tile, no password prompt. You are inside a tool your company bought last month and you never made an account on it. Here's the strange part. That application has never spoken to your identity provider. Not once. There is no connection between them, and there never was. Everything it knows about you arrived in your browser, hand-carried by you. In 2012, researchers pulled apart 14 SAML implementations to see how well that held up. 11 of them let a stranger walk in as anyone. I'm Nancy, and this is Trust Boundary. Every episode, we take one piece of your stack apart and find the line where trust changes hands, how it really works, what it looks like on the wire, and the one check almost everybody skips. SAML is how most of enterprise software still does that handoff. Ratified in 2005, built entirely out of signed XML and not going anywhere. By the end of this, you will read a real assertion and name the 4 checks before trust. And you will recognize the one check almost everybody skips. 3 parties, you in a browser, the service provider, which is the app you want, and the identity provider, the thing that already knows who you are. Draw the line here. The identity provider and the service provider are both held systems. Your browser is not. It is exposed, and it runs code from anywhere. It is also the only thing on this diagram that talks to both sides. So watch the boundary, because everything that matters crosses it. You ask the service provider for a page, it has no session for you. So it does not answer with the page, it answers with a redirect. Packed into that URL is an AuthNRequest, a small XML document. It says who is asking and where the answer should be sent. That is the HTTP redirect binding. The request is deflated, base 64 encoded, and stuffed into a query parameter. It has to survive being a URL. Your browser carries it across the boundary to the identity provider. Now you authenticate. Password, a second factor, whatever your organization demands. Or you do not. If you already have a live session, it just recognizes you. That is the whole point of single sign-on and the part users actually feel. The identity provider now writes an assertion, a signed XML statement that you authenticated, when it happened and what it knows about you. Then it has a delivery problem. A full signed assertion is far too big for a URL. So it comes back as an HTML form with a hidden field, submitted the instant it loads. Your browser posts it to the service provider's Assertion Consumer Service. That is the HTTP post binding and the moment trust changes hands. The app never heard from the identity provider directly, it heard from you. And there is a second way in, start at the identity provider instead. From an app launcher tile, it posts an unsolicited assertion straight to the app. No request was ever made, which means there is no in response to value to check. That variant is legal, and it is what most app launchers do. It removes one of the app's defenses before anybody attacks anything. The whole system rests on this document surviving a trip through hostile territory. Let us open one. Issuer names the identity provider that made this. The subject carries a name ID, which is who you are as far as this app is concerned. Subject confirmation data is the delivery address. Recipient must be this exact Assertion Consumer Service URL. Not on or after is how long the assertion is good for, minutes, not hours. In response to ties it to the specific request the service provider sent. If the app did not ask, it should be suspicious of the answer. Conditions carries an audience restriction, and this one names the service provider's entity ID. This assertion was minted for this app and no other. Then the statements. Auth statement is the proof of login, when you authenticated and how. Attribute statement is everything else the app wanted. Email, groups, roles, and wrapped around it, a signature made with a private key the identity provider never shares. The service provider checks it against a certificate the two exchanged in advance, in metadata, by an administrator long before you clicked anything. Notice what is not here. In this profile, there is no back channel at all. Compare it to OAuth, where the client redeems a code over a connection you never touch. Here, nothing is ever confirmed out of band. The signature stands in for that connection. That signature is doing all the work. So look at what happens when it is checked carelessly. The attacker does not forge anything. They start with a valid assertion, correctly signed for their own account. They are entitled to that, they just log in, then they rewrite the document around it. The original signed assertion gets moved somewhere else in the XML, still perfectly valid. And a second assertion is inserted where the first one used to sit. That second one is not signed, it says whatever the attacker wants. A different name, ID, different groups, administrator. Now, the naive service provider does two separate things. It asks, is there a validly signed assertion in this document? Yes, there is. Then it asks its parser for the assertion. And the parser hands back the one in the expected position. Different elements, both questions answered honestly. And the attacker is now signed in as you. This is XML Signature Wrapping, the class of bug that took 11 of those 14 libraries. The fix is structural, not a patch. Verify the signature over the exact element you then read and reject duplicate IDs. Do not hand-roll XML handling. Use a library people are still maintaining. Here's the boundary lesson. SAML puts your identity in the hands of the least trusted participant in the system. And it gets away with it because the document is signed. The signature is what makes an exposed courier safe, which means every guarantee you have is exactly as strong as how carefully it is checked. So go and check one thing today. Find your service provider's SAML configuration. Confirm that audience restriction is validated and that it names your entity ID. It is the easiest check to leave off because everything works perfectly without it. Until somebody hands your app an assertion minted correctly and legitimately for a different one. Every system has a line where trust changes hands. In SAML, it runs straight through your browser. That is one more boundary drawn. If this made something in your stack, click subscribe. There's a new one every day, and the next one is already in the queue. I'm Nancy. I will see you at the next boundary.